Hey, this is Leonard Zhao, and here is the experiment I built to demonstrate the total internal reflection. This is a redesigned experiment setup based on Akin's paper, an Arduino-based experiment designed to clarify the transition to total internal reflection. And the original method uses an optical pantograph to ensure the laser and the phototransistor are symmetrical on each side of the normal. The advantage of this method is that it converts the angle into electric signals that the Arduino can read, but this method needs the operator to take data manually. If you want to acquire data precisely, you have to adjust the angle degree by degree through moving the sliding block on the potential divider. But now, with this second method, I'm able to let it run automatically to take data for a range of incident angles through keeping the laser, or in this case my LED module, stay in the same position, and using a servo motor to rotate the semicircular glass block around its center to change the incident angle. A lower servo is used to control the arm with the phototransistor to automatically control the data within the range centered at the supposed reflected angle, and then output the maximum sensor value as the reflected light intensity for a specific incident angle. I designed the code in a way that it can either run automatically or be controlled manually. Here I'm gonna demonstrate the manual mode first. A potentiometer is used as the manual input of incident angle, so the upper servo rotates as I tweak the potentiometer. In this way, I can control it to turn into whatever angle I want, and I can also push the second button on the left to tell the phototransistor to take the current value and send it to the serial monitor. Just imagine a case in a classroom and you could show this device to the students to demonstrate how the light beam bends at the critical angle. You could also manually take a sensor data to examine the reflected light intensity at the critical angle. Next, I'm gonna push the first button to start running the entire loop for the auto mode. The sensor arm is at the initial position, and the upper servo tends to the initial angle, which is 20 degrees in this case. In each loop, for the sensor arm to take the data of 30 degrees around the supposed reflected angle, there are two parts. In the first part, the sensor arm goes from the lower limit to the upper limit, and it goes back from the upper limit to the lower limit. For example, when the incident angle is 20 degrees, the arm moves from 5 degrees to 35 degrees, namely plus or minus 15 degrees to that 20 degrees. As it moves from smaller to the bigger angle, I set the phototransistor to read the value for each degree. In other words, the interval here is 1 degree. I've tried 0.5 degrees as the interval, but the lower sensor often shakes, and it couldn't work for 0.2 degrees. When it moves backward, I don't let it take data because it tends to shake sometimes and may result in unreliable data. If it immediately turns to the next lower limit angle, after reaching the upper limit angle for the current incident angle, the abrupt movement will cause the servo keeping shaking around. So I just coded it to move back with a slightly bigger interval to avoid shaking and save time. Here I'm gonna speed up the video a little bit. Now, it's approaching the critical angle. The reflected light beam becomes visible and it's getting clearer. The lower servo I used does not have a really good precision, so for certain angles it just cannot reach the exact position. So it shakes. Also, this experiment could be improved by making the structure stronger and more stable. For example, it is made up of plastic and it's sensitive to vibration. Now the program is about to finish one loop for the entire auto mode, and it's gonna move to the initial position and start again. I just need to push the first button again to stop the program. And that's all for my experiment. Thanks for watching.